Alison Moyet, that is Love Resurrection on BBC Radio Berkshire. Just gone 25 to 11. So, are flights bumpier than they used to be? This is not great news for nervous flyers like me. Flight turbulence has apparently increased as climate change has warmed the planet, according to researchers from the University of Reading. Let's find out a bit more with the help of Professor Paul Williams now from the university. So I suspect this is quite complicated, Paul. Can you explain exactly what's going on here then?
Yes, good morning, Sarah. I'll try to not go into too many of the technical details, but we've had this idea floating around for quite a long time now that we expect climate change to be increasing aviation turbulence, so that in-flight bumpiness. But it's been, until now, it's been a theoretical expectation, really. We've arrived at it by running climate model simulations, increasing the carbon dioxide in those models, and calculating how much the turbulence increases. The big question, though, that we haven't been able to answer until a new study that we've just published is whether these increases in turbulence have already started. And it turns out that they have. There's, for example, 55% more severe turbulence over the North Atlantic today than there was back in the late 1970s when satellite observations began. So, yes, not very good news for nervous flyers. And, there are statistics that something like 1 in 4 of us has a diagnosable fear of flying. And you mentioned perhaps that you're one of them. So I'm sorry to be the bearer of bad news.
Yeah, this doesn't bode well for my trip to Turkey in the summer at this stage, Paul. I won't lie to you. How did you find out that there'd been an increase in actual turbulence then? I mean, do flights record the amount of turbulence that they encounter?
Flights do, but that's not what we've done in this study. We're talking here about a kind of turbulence. It's called clear air turbulence, and the clue is in the name there. It's invisible. So the pilots can't see it, the radar in the cockpit can't see it, and even satellites can't see it. But there's a workaround, because what we can do is what satellites can see is the 3-dimensional shape and structure of the atmosphere, including the jet streams, which are these very powerful air currents. And it turns out that if we have information about the structure of the jet streams, and in particular how rapidly the winds are changing from one part of the atmosphere to the next, we can calculate using a set of equations how much turbulence would have been being produced by the jet stream at that moment in time. And when we analyze that 4-decade-long record of atmospheric observations, we do find these enormous turbulence increases that are consistent with what we've been predicting for the past decade. But now we finally have the evidence that these changes have indeed already started.
So in very basic terms, what causes turbulence?
Well, this invisible turbulence is caused by things going on in the jet stream. The reason we have jet streams in the first place is because it's obviously very warm in the tropical parts of the planet and very cold near the North Pole. And that gives us a temperature difference, which sets up pressure patterns that drive the jet stream. And what climate change is doing up in the upper atmosphere at 40,000 feet, which is where aircraft tend to cruise, climate change is actually because of feedback effects where warming creates further warming because of effects that kick in. The temperature pattern change is not uniform, and that north-south temperature difference is being made stronger because of climate change, and it follows, therefore, that the amount of what we call wind shear in the jet stream, a measure of how strong the jet stream is, it has also been strengthening, and we have a good records and observations of that effect taking place as well since the 1970s.
So geographically then, are there parts of the world where you are more likely to encounter turbulence than others?
Yes, there are, and it depends on the kind of turbulence. And in fact, there's pretty much nowhere on the globe that you can escape completely from turbulence, because in the tropical parts of the planet, there's a lot of rising warm air, which leads to clouds and storms. And that itself is, of course, a big source of turbulence if you're flying. But when you get outside the tropics and into the mid-latitudes where we are in the UK, there's this transition from that storm-related turbulence to this invisible clear air turbulence, which is anywhere where there's a jet stream. And the jet stream in the Northern Hemisphere goes all around the hemisphere, really, over Europe, Asia, the Pacific, North America, and the Atlantic. And flying over mountains is typically quite turbulent as well. The way the air blows over the mountain can generate atmospheric waves that break down into turbulence. So really, it's very hard to find a part of the world that is turbulence-free.
I can feel my palms sweating already. The thought of flying over a mountainous region and being hit by turbulence is not something that I want to contemplate. The thing is, though, and I realise that, this is very complex research. How can it be used, though, by the aviation industry? Is it merely informing them, but there's nothing else that can be done about it? Because surely there are limits to what you can do to avoid this or to mitigate its impact.
It's a good question, and the airlines are certainly asking us that for that information. There are some turbulence forecasts that pilots use, and air traffic controllers and flight dispatchers. Just like weather forecasts, but instead of plotting maps of temperatures and rainfall, they're plotting how strong the turbulence will be over the next 18 hours or so. So, just like weather forecasts, they're not perfect. Sometimes they get it wrong, but more often than not, they're correct. But I think one thing we could do is we could work on improving those forecasts so the pilots have the best possible information before they take off, really, so that they can plan the smoothest route that's available.
Paul, thank you so much. That's Professor Paul Williams from the University of Reading explaining a very, very complicated situation pretty well, I would say. Right then, I want to hear about your turbulence stories, please. I'm automatically transported back to a flight back from Italy, of all places, about 5 years ago, where I was a complete nervous wreck. I've never experienced turbulence like it. And it was coming back from the holiday. So we were with people who we'd met on board the aircraft. And one of the people that I'd become friends with was beside herself. She was literally in tears. And every time there was a huge drop or particularly shaky turbulence, she would ask for another drink. And by the end of the flight, she could barely walk off the aeroplane. Tell me about your most turbulent flights then on 08000 321 333 on the WhatsApp, starting your message with the word Berks. And while you're doing that, here are the Jonas Brothers on BBC Radio Berkshire.